Back in 2010, when I started programming, the LAMP stack was at the height of its popularity. So, naturally, an entire generation of developers grew up with the idea that MySQL is the best open source database. It was easy to set up, easy to explain, and forgiving enough that you could misuse it for years without immediately feeling the consequences. However, it might surprise you to find out that despite its popularity, MySQL is not the best open source database out there. And the real powerhouse has been around for just as long, quietly doing things correctly instead of conveniently. I am talking, of course, about PostgresSQL. You'll find a lot of stories on the internet of developers who were able to replace pretty much their entire backend stack with Postgres, thanks in part to the incredible number of built-in features it offers out of the box. On top of that, backend-as-a-service tools like Supabase are relying heavily on Postgres because the database is powerful enough to sit at the core of authentication, storage, real-time updates, and access control. This is the detail most of us are overlooking. PostgresSQL competes with entire infrastructure categories, not just with other databases. When a database enforces rules, validates data, streams changes, and exposes a clean, composable surface, large parts of traditional backend architecture disappear. So, in the next few minutes, let's take a look at some of the basic and advanced Postgres features, and by the end of the video, you'll see that PostgresSQL changes how you think about backend design. First, let's start with a quick SQL crash course, because I know we all consider ourselves SQL experts, but somehow we always forget what the ACID acronym stands for. So, at its core, Postgres is a relational database management system which uses SQL to interact with data. This data is structured in tables with rows and columns, which allows us to maintain a strict relationship between different entities. You can perform CRUD operations with basic commands like insert, select, update and delete. You can aggregate data from multiple tables in a really efficient manner with joins, and you can update data from multiple tables in one single unit of work through transactions. If queries are slow, you can create indexes to speed them up. And when your app is used by thousands of users, these operations have to be performed concurrently with predictably reliable outcomes. Here is where ACID comes into play. It's the gold standard for database reliability, and while many databases claim to follow it, Postgres is famous for its strict adherence to these 4 pillars. Atomicity requires that a set of changes either all happen or none do, so there are no half-finished updates. Consistency makes sure your data always follows the rules you've defined to avoid invalid or broken entries. With isolation, multiple users can use the database at the same time without interfering with each other, and durability ensures that once something is saved, it stays saved, even if the server crashes right after. The reliability of the data is one of the main responsibilities of a database, and constraints are how Postgres enforces that responsibility instead of outsourcing it to application code and relying on the programmer's work ethic on a random Monday. Constraints are explicit rules baked directly into the schema. A not-null constraint guarantees that critical fields are always present. A unique constraint ensures that values like emails or usernames never silently duplicate. A check constraint lets you define domain rules directly in SQL, like making sure a quantity is positive or a status field only contains allowed values. Every constraint you move into the database is one less rule duplicated across services, controllers, background jobs, and scripts, and the database becomes the real source of truth across your entire stack. Another basic but often underestimated feature in databases is data types. Most developers are used to dealing with strings, numbers, and booleans, but PostgresSQL offers a wide range of options. Arrays, JSON, enums, UIDs, composite types, and even geospatial types are all offered out of the box because Postgres supports real-world requirements natively. Take JSON for instance, which is an interesting use case because it allows you to continue using Postgres for both SQL and NoSQL use cases. The JSON and JSONB types in Postgres are a perfect example of how the database lets you bend the rules without breaking them. You can store flexible, nested, schema-less data directly inside a column. This is handy when you have dynamic fields, third-party payloads, or user-generated content that doesn't justify a full schema migration. So you can add a new column in an existing database and then store arbitrary key-value data in it. But the really interesting thing is that we are not sacrificing performance or control. With JSONB, Postgres stores the data in a binary format that supports indexing, so we can create a genindex to speed up key lookups. Then, we can query our table like this. This is the kind of hybrid flexibility that's usually reserved for dedicated document stores like MongoDB, but in Postgres you still get joins, constraints, transactions, and the real query planner. And we can take things even further and combine structured and unstructured logic. And this native integration of custom types applies to all kinds of advanced data. For instance, Postgres supports spatial data through an extension called PostGIS, which turns the database into a fully compliant geographic information system capable of storing, querying, and analyzing spatial data with precision. In practice, with geography columns, you can first insert a set of coordinates and then perform interesting operations like trying to find all locations within 5 kilometers of a user's position. Yes, this is all supported natively by Postgres, and no, we didn't have to add a third-party dependency like Google Maps to our stack. It's often said that Postgres is an object relational database, and that description is more literal than most people realize. Postgres lets you define your own types, attach behavior to them, and treat data as first-class domain objects instead of loosely structured blobs. You can create custom types, functions, and operators, and then use them directly in queries. But before looking at some more interesting Postgres features, here's your trivia for the day. Postgres started as the successor of Ingress, which was an academic research project at UC Berkeley in the 1970s. What's interesting is that the project was backed by the United States government. During those years, US agencies and military research arms poured funding into universities to stay technologically ahead of the Soviet Union. While Ingress proved that relational databases were reliable and commercially viable, it had limitations in how it handled complex data types. So, in 1986, Michael Stonebreaker began the Postgres project aimed to create a system that could understand objects and rules, not just simple rows and columns. So, in a way, we have to thank the Cold War for object relational databases even existing. Back to the video, one of the most powerful and criminally underused features in Postgres is row-level security. RLS lets you define access rules directly on table rows. So instead of filtering rows in application code and hoping every endpoint remembers to do it correctly, the database itself decides which rows are visible for a given user. If a row doesn't match the rule, it simply does not exist from the perspective of that query. At a practical level, this means you can say things like users can only see their own records, admins can see everything, or an organization member can access rows that belong to their organization. These rules are written once in SQL and they apply to every query, no matter where it comes from. This completely changes how you think about security, because authorization is no longer scattered across controllers, middleware, and services. So even if your application has a bug, the database still refuses to leak data it shouldn't. So, until this point, we saw that Postgres can act as a NoSQL database, it can replace geospatial libraries, and it can handle app authorization for you. This is just the beginning, because guess what? Postgres can also act as a lightweight message broker. With Listen and Notify, Postgres gives you a built-in publish-subscribe mechanism that works natively over SQL, so basically you don't actually need Kafka or RabbitMQ anymore, at least not for smaller use cases. In practice, you would start a session or connection, listening to a channel to wait passively for notifications. Then, from anywhere else in the app, you can start sending messages to that channel. Of course, you can pass in structured data like JSON and even send notifications after successful operations like inserting or updating. In tools like Supabase, this powers real-time updates. When a table changes, a trigger fires, a notify is emitted, and the client gets a WebSocket push in milliseconds. And with Kafka and RabbitMQ removed from the stack, let's also deprecate Elasticsearch. Postgres supports full-text search, so you can create indexes on text columns that tokenize and normalize content automatically, taking into account word variations, stop words, and language-specific rules. You can rank results by relevance, and you can combine full-text search with traditional SQL queries and even search inside JSON fields. And, on top of everything else, Postgres comes with multilingual content out of the box. And if you think Postgres can't possibly replace anything else, you are wrong. Foreign data wrappers are Postgres extensions that let you query external systems as if they were native Postgres tables. So Postgres becomes a federated query engine where you can mount a remote Postgres instance, a MySQL database, a CSV file, and a REST API directly into your schema. From that point on, Postgres treats external sources as extensions of itself. So you can join, filter, aggregate, and even insert or update in some cases, because your app doesn't care whether the data lives locally or halfway across the world. So, if you are not considering Postgres for your tech stack, you are missing out. There is a reason all these companies are using it. Where Postgres really shines is in allowing you to simplify your tech stack and remove some of the complexity that we've come to accept as normal. So while the tech world keeps spinning up microservices, duplicating logic across layers, and overcomplicating everything in the name of scalability, Postgres quietly does the opposite. Please check out one of these videos if you want to learn more about databases, don't forget to aggressively smash all the buttons, and until next time, thank you for watching.